we're going to take a look at reflections. And the key with reflections is what we call relative location, which is your distance from the axes. So I'm going to start with point A, which is at 2, 3, and it's in quadrant 1. You really need to know your quadrants because the rules for coordinates with reflections and rotations have to do with which quadrant you're in. So the first thing I'm going to do is I'm going to reflect this point over the y-axis. So that means I am going to flip my point from the left to the right. You can either go from left to right or right to left. And you'll notice this isn't going to affect whether it goes from the top to the bottom. It's going to stay on the top because it starts on the top. So your y-axis controls left versus right. Whereas your x-axis controls, top to bottom. Okay, and I'll flip over the x-axis in just a second. So when we talk about relative location, we're going to preserve the relative location. So we want to keep the same distance from the axes. So currently you'll notice that this point A is 2 spaces, 1, 2, away from the x-axis. That means when I reflect it, I need to preserve that distance. I want it to be in the same relative location. So it's going to be 2 spaces from the y-axis. So this is 2 spaces from the y-axis here. I think I said x-axis, I meant y-axis, and 2 spaces from the y-axis here. And then you'll also notice that this is 3 spaces from the x-axis. So I need it to be 3 spaces from the x-axis when I reflect it. So my image, my A prime, is now at -2, +3. So you'll notice that the relative location is the same. It's still 2 spaces from y and 3 spaces from x. You'll also notice that the numbers 2 and 3 did not change. What changed was the quadrant, and that means that the x values in quadrant 2 are always going to be negative. And that's why these quadrants are important. Now I'm going to reflect point A, over the x-axis. This is going to change whether my point is going to be at the top or the bottom. Currently, it's on the top. When I reflect it over the x-axis, it's going to move to the bottom. But I need to preserve the distance. So here, it is 3 units away from x. So I am going to count 1, 2, 3. And it's 2 units from y. So I am going to count 1, 2. This has preserved the relative location, and we'll make that double prime. And notice that the numbers of the coordinates did not change. We still have a 2, we still have a 3. That's because we're preserving the relative location. We're keeping the distance from the axes the same. In this quadrant, all of the x values are positive and the y values are negative. So because it went from quadrant 1 to quadrant 4, this became, it stayed a +2, but it turned into a -3. So this is a one-dimensional reflection. It's a single point being reflected. Let's take a look at what happens when we make this 2 dimensions. So I'm going to make a line. I'm going to start it at 3, 4, and I'm going to take it, that's not a very straight line. I'm going to take, sorry, -4, I totally said that backwards. I'm going to start it at -4, +3, and then I'm going to take that to -1, +2. So we're going to call this A, and we're going to call this B. And notice I'm starting this in quadrant 2 this time, just to give a different directionality and change in the coordinates. So when you do a 2-dimensional or 3-dimensional, as you'll see, reflection, the key is to do this one point at a time. You don't want to try and reflect the whole image together, because then that makes it harder for your brain to keep things straight. So first I'm going to reflect point A. So point A, I'm going to count to the y-axis is 1, 2, 3, 4. It is 4 units from the y-axis. If I want to reflect this over the y-axis, I need to make it 4 units from the y-axis on this side. 1, 2, 3, 4. It has to be in the same relative location. This is also 1, 2, 3 units from the x-axis. Therefore, I need to preserve that location and make it 3 units from the x-axis over here. So now I have point A prime, and my coordinate went from -4, +3, to +4, +3. Because in the first quadrant, all coordinates are positive. Now let's reflect this point. Oh, sorry, I need to reflect the second point. So now I'm going to reflect B. B is only 1 unit away from y. So when I reflect it over the y-axis, it's going to be 1 unit away from y. And it's 2 units away from x. So when I reflect it, it needs to stay 2 units away from x. That means this is going to be B prime, and I've preserved the relative location. So our pre-image, B, was at -1, +2. Our image is at +1, +2. So you'll notice again that these coordinates are changing the sign, but not the numbers themselves, because what you're doing is you're simply reflecting it into a different quadrant. Let's take a look at what happens if it goes over the x-axis. Again, I'm going to reflect 1 point at a time. So this pre-image A is 3 spaces from x, 1, 2, 3, and it's also 4 spaces from y, 1, 2, 3, 4. So now I've preserved my relative location, A double prime, and this has turned into -4, -3, because in quadrant 3, all coordinates are negative. And now I'm going to do B. So B is 2 units away from x, 1 unit away from y, and so now I've preserved this, and it's become -1, -2. Now I can connect my points. And something else about relative location is that the relative location within the shape will be reversed as well, because it's a reflection. So notice here in our pre-image, A is on the top left. When we reflect it across the y-axis, it's on the top right. When we reflect it across the x-axis, it's on the bottom left. And if you think about that, that makes sense, because when you reflect it across the y, you're impacting that left-right. So it was on the top left, and now it's on the top right. It didn't change that it was on the top, it simply changed that this point's location relative to the other points in that shape changed to the right-hand side. Here, because the x-axis impacts top and bottom, it went from top left to bottom left. It didn't change that it was on the left. It changed that it was on the bottom of the shape relative to the other points in the shape. So that's what we talk about with relative location as well. It's not just the distance to the axes that we're talking about, but in relationship to the other coordinates in the shape or in the image. Now let's take a look at a three-dimensional reflection. Oh, whoops. There. Okay. So I'm going to draw a triangle. Oh, look how beautiful my triangle is. Love my triangle. So we're going to call this point A. We're going to call this point B. And this is going to be point C. And point A is at -5, -2. B is at -4, -4. And C is at -2, -3. Okay? So I'm going to reflect this over the y-axis. I need to keep my relative locations the same in terms of distance, and my relative location in terms of the shape itself is going to be reversed. So let's take a look at A. So A is 1, 2, 3, 4, 5. 5 units from the y-axis. That means it needs to be 1, 2, 3, 4, 5. 5 units from the x-axis here. And then it is 2 units, 1, 2, from the x-axis. So I have reflected point A, and it's become A prime. And you'll notice again that the coordinates are all the coordinates here are the positive x and the negative y because we're in quadrant 4. I'm going to do the same thing for B. B is 1, 2, 3, 4. So B is 4 units away. So I'm going to go 4 units away here. And I'm going to go 1, 2, 3, 4. 1, 2, 3, 4 units here. Now I've created my B prime, and my x value is positive and my y value is negative, but I've preserved that distance, that location relative to the axes. And now I'm going to do point C. C is 2 units from y, so now I get 2 units from y. And it is 1, 2, 3 units from x, 3 units from x. So I now have created my C prime. And this, again, because it's in quadrant 4, the x is positive and the y is negative. Now I can check my relative location in terms of the shape itself. So, whoopsie, that got a little twisty. Let's fix that. There we go. Oh, it's being difficult on me here. Okay, let me redraw that. There we go. I'm just not going to make it a triangle because it's going to be too. Oh, nope. Guess it just likes that. We'll pretend that that's not there. We'll pretend that it looks better. Actually, I'm going to just take, oops, there we go. Okay, I fixed it. All right, so the A was in the top left. So it's the top left point. Here it's the top right point because it went over that y-axis. B was bottom center. B is still bottom center because it's the center, not left or right. And C was middle right, and now it's middle left. So it was on the right-hand side, now it's all the way to the left-hand side of the shape. Now I'm going to reflect this across the x-axis. So we have point A is 2 from the X and 5 from the Y. And this gives me, I'll make this A double prime. And because this is in quadrant 2, my X is negative, but my Y is positive. My quadrant, or my B is 4. 1, 2, 3, 4. So 1, 2, 3, 4. And it's also 4 from the Y. 1, 2, 3, 4. So I've got B double prime, which is negative 4, positive 4. And then I have C, which is 1, 2, 3, 1, 2, 3 from the X and 2 from the Y. So I have C double prime, and that coordinate is negative 2, positive 3. So again, my distance or location relative to, oh, see, that one worked. Yay. The distance relative to the axes is preserved, and the relative location is reversed in terms of top and bottom. So in my pre-image, A was on the top left. Now in my image, A is on the bottom left. B was on the middle, the bottom middle. Now B is on the top middle. And C was on the middle right, and now it's still on the middle right. So if you are looking at an image and you're trying to make it, if you're looking at a pre-image, trying to make it into an image and reflect it, the key is that relative location from the axes, 1 point at a time. Now, if you're given 2 images and asked, is one a reflection, you can use this as well. And here's what I mean by that. So let's say you're given the image ABCD, and then you're also given, or you're given the pre-image ABCD, and you're given the image A prime, B prime, C prime, D prime. And you're asked to determine whether or not these have been reflected, this shape has been reflected. Well, you definitely want to look at the relative location to the axis and axes, and you want to look at relative location within the shape itself. So the first thing I notice is that point A is 1, 2, 3 spaces from Y, and it's also 1, 2, 3 spaces from Y here, which is good. Okay, so all of the points are on this side are 3 spaces from Y. That's a pretty good start. Now I'm going to look at how close they are to X. So my pre-image is 1, 2 spaces from X, but my image is only 1 space from X. That means that this probably isn't, it's certainly not just a reflection. If we had a reflection and a translation, it could happen, but it's not a reflection because it's not the same relative distance from the axes. Now, I also want to look at the relative location of the points. So if I look at A is in the top left. When I look at A prime is still in the top left. Well, this has been reflected over the x-axis. And when I look at the x-axis, that tells me that my points in my shape need to switch top and bottom. If they started in the top, they're going to end in the bottom, and vice versa. Well, A is starting on the top and ending on the top. So this is not a reflection. Now what about this? Here we have image, the pre-image ABCD. Oops, that's supposed to be a D. And we have the image A prime, B prime, C prime, D prime. Now let's take a look at relative location in the shape first. Here, the A is in the top left. A prime is in the bottom left. That means it has changed from top to bottom. That's a good start. Now let's look at its location relative to the axes. So it is 1, 2, 3 spaces from Y and 1, 2, 3 spaces from Y. That's another good sign. Now let's look at the spaces relative to the x-axis. 1, 2, 1, 2. And because this is a rectangle, I can see that the other points are following because they're still all right angles. And they are also, if I look here, this is 1, 2, 3, so it's still in the relative position. So this is a reflection over the x-axis because all of the points have changed relative location from top to bottom, but they all stayed in the same relative location in terms of the relative distance to the axes. Hopefully that helps you visualize what a reflection looks like.